Hello, my name is Angelica Buffaloe, and my final project is titled Machine Learning Approaches for Accurate Heart Disease Detection, a Comparative Study. So the agenda with this project, first, we're just getting a basic overview about what I did. Second, we are going to look at some heart disease insights and learn basic information about it. Number three is the meat of the presentation, and I will be discussing the methodology. Four is the results that I found. And finally, the fifth is the conclusion of the study. So, in this project, I explored and compared several different machine learning models to analyze and predict disease using key health and lifestyle factors. I primarily focused on four models: logistic regression, decision tree, random forest, and support vector machine. To evaluate the performance of each model, I focused on the accuracy, precision, recall, F1 score, and AUC ROC metrics. So, heart disease, why should we care about addressing this problem? According to the CDC, in 2023, more than 900,000 people died from cardiovascular disease, which is a group of conditions that affect the heart and blood vessels. Heart disease, which is a subset of cardiovascular disease, is the leading cause of death across most demographic groups in the United States. The CDC also states that healthcare services, medications, and lost productivity due to death cost the United States over $417 billion in a year from 2020 to 2021. And with the graph to the right, we can just get an idea from 2018 to 2020 what areas were suffering with heart disease the most based on age. So there are actually several types of heart diseases. Some of these include arrhythmia. This is where the heart has an irregular heartbeat. Cardiac arrest, where the heart suddenly stops beating altogether. And coronary heart disease. This is the most common one, where major blood vessels to the heart becomes blocked, which results in restricted blood flow to the heart. As I mentioned a second ago, coronary heart disease is the most common type of heart disease. The CDC states that in 2022, it claimed the lives of over 370,000 people. Even though heart disease is a leading cause of death for most demographics, there are some racial groups that have a higher percentage of death rates compared to others. The top three racial groups that die from heart disease in 2021 were people who were Black or non-Hispanic, which was 22.6%, Asian, which was 18.6%, and Native Hawaiian or Pacific Islander, which was 18.3%. So, what actually causes heart disease? Some risk factors. The biggest factors that contribute to heart disease are smoking, high blood pressure, and high cholesterol. Some other contributing factors include being overweight or obese, having an unhealthy diet, and not getting enough physical activity. Also, diabetes and drinking an excessive amount of alcohol. What are some symptoms of heart disease? Some symptoms include heart attacks. So that is feelings of chest, upper back, or neck pain, nausea, vomiting, dizziness, and extreme fatigue. Arrhythmia, as mentioned before, which is palpitations in the chest, and heart failure, which is having swollen feet, ankles, legs, or abdomen, and having a shortness of breath. Now on to methodology. Information about the data set. So this was a synthetic data set named Heart Disease Dataset 3000 Records in 2025, which was obtained from Kaggle. The authors stated that the dataset contains clinical and lifestyle attributes for individuals with a binary target indicating the presence of heart disease. The data is numeric and categorical encoded, which is suitable for predicting a heart disease risk. So there were several different variables in the data set. Um, These variables include the age of the individuals in years, biological sex, 0 for female, 1 for male, the type of chest pain that they are experiencing. There's an encoding of typical, atypical angina, non-anginal, and asymptomatic. The resting blood pressure measured on admission, serum cholesterol levels, the fasting blood sugar levels, with 0 being false, 1 being true. The resting electrocardiogram results, which are encoded categories. Maximum heart rate achieved during exercise. Exercise-induced angina, with 0 being no, 1 being yes. ST depression induced by exercise relative to rest. Slope of the peak exercise ST segment. This is also encoded categories. The number of major blood vessels, which are 0 to 3, colored by fluoroscopy. Um, Thalassemia status, which is encoded. Commonly 3. Common is 3, which is normal. 6 is a fixed defect, and 7 is a reversible defect. And then finally, the last variables mentioned in the set are the current smoking status, diabetes status, body mass index or BMI, and the binary target is the presence of heart disease, 0 being no, 1 being yes. So, pre-processing. Before working with any model, I wanted to pre-process the data set. So I uploaded the CSV file into Colab and created a data frame in order to explore. Um, I named the data frame heart disease just because that's easy. And I also checked for any missing values, and it was stated that there were no missing values. So, because of that, I was able to move on. So after checking for null values and uploading the data set, I encoded and normalized the data. So I uploaded the label encoder, created an instance, and then encoded the heart disease column, which is, as mentioned before, the binary target. Also checked if everything worked. I use cholesterol as a example feature just to see what would come out. Um, I tested it, trained it, split it. Then I ended up normalizing that data. And these are the results that I came up with. So all of the features are on a similar scale, and because of that, the models can produce accurate and stable results, or it is possible for that to happen. So the first model that I wanted to explore was logistic regression. I imported the necessary modules such as test train split, logistic regression, and all of the metrics from sklearn. So accuracy score, precision score, recall score, F1 score, ROC, AUC score. Um, so initially, I only wanted to focus on four features, which were cholesterol, smoking, BMI, and I'm pretty sure age. But when doing this and running the logistic regression model, I was coming out with scores of 0. So I decided to add a total of 9 features. And those features are cholesterol, smoking, diabetes, BMI, blood pressure, age, sex, resting, blood pressure level, and etc. So I made heart disease my binary target and created a data frame for the features in the target, test train split the data, and then I trained and normalized the data and created more data frames and created predictions. So next, after applying the logistic regression model, these are the evaluation metrics that were the result. So, as I stated before, I'm only focusing on accuracy, precision, recall, F1 score, and AUC, ROC scores. And so 62% of the predictions were correct, 62% accuracy. 52% of the patients who were predicted to have heart disease did. So precision. There was a 42% score based on precision and recall. And there was also a 65% score that showed that the model can recognize patients with and without heart disease. So the model performed just okay, and it provides a basic um, baseline when compared to the other models. So next, I want to see if decision tree would be any better. So the next model is decision trees. So when using decision tree, I imported the decision tree classifier, plot tree, and matplotlib modules. I kept the same features and tar binary target because, as I mentioned before, I wanted to use more features just to get something. After testing, training, splitting the data that I use for logistic regression, I'm just going to use the same exact thing. But with decision tree, I used Gini and entropy and created a decision tree plot. So I had to train the decision tree with entropy and then also define a function and define the class names in the plot. After that, I made some visualization. So I trained and visualized the decision tree with entropy and Gini. Then I made predictions for both of the test sets. And after doing all that, these were our results, and it's a little hard to see, but after um, playing around with the customization of the plot, this is the best that I could get it to where it was kind of readable. Having 9 features really crowded everything, but as I stated before, I wanted to have more features rather than less, just to get better metrics than what I initially got. And then this is the other image that was produced after creating the decision tree. So with the decision tree metrics, they were slightly higher compared to the logistic regression model. So the decision tree model had an accuracy of 64%, a precision score of 54%, a decision recall score of 43%, a F1 score of 48%, and AUC/ROC of 65%. So um there was a score that showed that the model can recognize patients with and without heart disease, which was the same as logistic regression. So yeah, the scores were slightly better, but still on the moderate end. So next, I used the random forest model to see if the metrics will continue to improve. Okay, so with Random Forest, I imported Seaborn's sklearn Random Forest classifier in the confusion matrix modules, and then trained the Random Forest classifier and created a confusion matrix. The results of the confusion matrix showed that the true negatives were high, while the true positives were low. And it was also found that there were a total of 69 false negatives. So, next. The metrics with the random forest, accuracy of 62%, precision score of 52, recall score 35, F1 score 42, ROC AUC score of 65. So far, the decision tree model has performed the best. Um, but we still have one more model to go, and that final model will be the support vector machine. So finally, we are testing out the support vector machine. Out of the four models that I explored, I did like this one because of its simplicity. It's a very easy model to use. I began by importing decision boundary display, SVC, and matplotlib again, just, for consistency. And then I had to scale the numerics and then the training data, testing data. I also added a balance classifier because I was kind of getting issues with how the metrics were coming out. And so I added that just to balance things out. Then I trained on the training data and made some predictions on the scaled test data. So, comparatively, the support vector machine performed the lowest out of all four models. Um, It had an accuracy score of 61%, precision score of 50%, recall score of 63%, F1 score of 56%, and ROC AUC score of 61%. So definitely on the lower end. However, 50% of the patients who predicted to have heart disease did, and 63% of true cases were caught. So this is the highest out of all of the models. Another high score was the precision and recall. That was the highest out of all four. And yes. So comparatively, between all four models, Decision Tree had the highest accuracy and it also had the highest precision. So the accuracy was 63% and the Decision Tree precision was 53%. So Port Vector actually had the highest recall and the highest F1 score. The recall being 63% and the F1 score being 55%. With logistic regression and random forest, they both had the highest ROC AUC score, which was 64%. They were the exact same score. So they all kind of, oops, sorry. They all performed, um, as I mentioned earlier, kind of moderate, but it was just interesting to me that the scores weren't higher. And I'm not sure if that's an error on my end, which it probably is, or is it a problem with the data set? So that being said, each model showed moderate performance when predicting whether a patient may have had heart disease. Although adding more features provided more information, the metrics remained about the same. So I feel like exploring more advanced modeling techniques could potentially result in better metrics. Maybe the metrics and the models that I use, maybe the models that I use were just too basic. And maybe there was some pre-processing that I might have missed. Because yeah, the everything was only a little bit over 50%. I think the highest was maybe 64, 65%. So nothing even reached 70%. Um, so yeah, maybe in the future I could use different models that are a little more advanced that I know how to use. And all of the information on heart disease came from Center for Disease Control and Prevention, fact sheet, and the Heart Research Institute. So now I am going to show how I did my coding. Okay, one second. Okay, oops. So these are all of my codes that I used and all of the images that were produced. But if you click run all, nothing's going to work because I have to upload the CSV file into the Colab environment. So I'm just gonna let it run just so you can see that like everything is not going to work. Well, while that's doing that, it'll get to it. So now I'm just gonna upload. Okay, there we go. So as you can see, I need to upload it because nothing worked. So I'm gonna go to upload to session storage and find my heart disease data set. I had to convert this to a SFV file. So now that it's uploaded, I should be able to get it to work. So I imported pandas, imported the data set, created a data frame, and printed the data frame so that I could see if it worked and what I'm working with. As mentioned before, I tried to check for null values, and there weren't any, as it says right here. And then I encoded the data. I encoded the heart disease column since that was our binary target, checking to see if everything is working. As I mentioned before, I used cholesterol just as an example. This was before using the 9 features that I chose. This was just kind of like a test to see what would come out. Then I tested, trained it, split it, checked for the result, and what I ended up with is this, as I showed before. So with logistic regression, I imported all of these modules and I upped my features. As I mentioned before, I only started with 4, but then my metrics were coming out with some things equaling 0, so I figured I should add more metrics. But when I added all metrics too, it didn't really change, so I didn't even really have to add every single variable. Like my 9 would have sufficed because the scores were still the same. Like I tested a bunch of different variables. So yeah, I created a data frame and the target is heart disease. Test train split as always. Then normalizing the data, predicting for scaled testing data, making a bunch of predictions, and oh, let me hit run. And these were my results, and these are just the accuracy scores that I mentioned earlier. So moving on to decision tree, I'm going to run this and I'm using the same features, same target, same process as logistic regression. But with this one, I have to use Gini and entropy and create probability and predictions. And these are the two images that were produced that I mentioned earlier in my slideshow. And um, and these are the metrics of that. Next, I did random forest, going to run that. And these are the import modules that I use. And what's different with this one is that I created a confusion matrix. So I made that confusion matrix with the Y testing and the Y predictions. And with some customizations, this is what the image resulted in, which I showed earlier. And these are the metrics. And finally, the most simple model to do was support vector machine. And all I had to do was scale the training and testing data, kind of balance it out. I was just kind of playing around just in case, like I said, I was doing something wrong on my end. So I figured I should just keep the class and the data balanced. But the scores were pretty much the same, you know. Yeah. And then finally, just so we get a better visual of what we're working with, I made a data frame of all of the metrics next to each other just to see um, how everything came out. So, that being said, that is the end of my presentation. Um, Something that I learned is that I should explore different models and just try it. I stayed pretty basic with this, and I think maybe if I would have used more advanced models, maybe my results and my metrics would have been better. Also, paying attention to pre-processing more because maybe I missed a step, and that's why my metrics were the levels that they were. So, that being said, thank you for listening to my presentation, and if you have any questions, please let me know.